Good morning, everybody. I hope you are enjoying the conference so far. So, welcome to the third session of the first day, that is industrial applications. We have two presentations lined up for today. First one is from Tecnalia with Paul Daelman as the speaker, and the second one is by EVP Corporate Research by Tjerngren. So you can actually talk to both of them during the exhibition session, which will be happening during the lunch break. Also, we have a couple of polls for you during the session, and you could, as always, ask your questions in the chat. So first up is Paul Daelman from Tecnalia Research and Innovation, who is a PhD student there. So over to you, Paul.
Thanks, Arch. So good morning, everyone. I hope that you can hear me properly and that you can see my screen also. Hope that you're all doing fine, and thanks to be present to this presentation. First, I will be doing a little presentation of the Tecnalia structure with few figures and a little video of what we are actually doing here in the robotic laboratory. And to follow, I will be presenting you the ScanNPlan application, which has been an opportunity for us to give some visibility to the ROS framework. And we will be concluding with a live demo of the FANUC manipulator executing its ScanNPlan application. So quickly, what is Tecnalia? So we are a research and technological development center based in Spain. In fact, we are the first private organization in Spain in project consulting, participation, and leadership for the European Horizon 2020 program. And we are gathering almost 1,500 collaborators, providing different services to our clients. And we are also dealing with various domain as health, energy transition, sustainable mobility, innovative urban ecosystem, and advanced manufacturing. So here we are based in the Basque country. We are actually in a very industrialized region. And according to the 2017 Regional Innovation Scoreboard, the Basque Country has been classified as a strong innovative region by the European Commission. So we actually have a high and a strong industry here in the Basque Country, gathering machining tool manufacturers, train and bus manufacturers, and also big supplier for the automotive sector. And gathering this industrial activity with the biggest investment for R&D in Spain, it makes a good environment to introduce the ROS-Industrial problematics. More particularly, here in Tecnalia Robotics, we are dealing with various aspects of the robotic. So here I won't show you the entire video because it's quite long, but this is a result of some projects we are dealing with. We are working with some mobile manipulator, also dealing with things as perception of human or parts, working with collaborative robots, implementing various applications oriented to communication and collaborative robotics. So feel free to ask more information about that during the exhibitor time. We will be present to give you some information if you want to. So that's for Tecnalia. So why we decided to show the ScanNPlan demo. Initially, we plan to present this demonstration during the Biennale International de Máquina Herramienta, the International Machine Tool Exhibition, which should have been taken place in Bilbao this year during the month of May. But due to the COVID crisis, this event has been cancelled, which is quite sad for us. But the objective there was to show that ROS is providing helpful tools for complex robotic application, and that an application as the ScanNPlan dealing with various problematics difficult to overcome with traditional programming, as huge amounts of different parts, maybe unavailable CAD models, including flexible and deformable parts in application. All those problematics are quite difficult to overcome with traditional programming, and requires a lot of time and resources to do it without the ROS environment. So this demo is actually running in the robotic lab of Tecnalia since the month of May. So we were trying to use this opportunity to share this demo with our different collaborators, showing this application to the different visitors came to us. So we've been able to reach people from different environments, some of university, some of local manufacturers, and others big company as people from Websol or the Kawada company. And it gives us the opportunity to show that to industrial actors that the ROS framework is actually growing and providing new tools every day, considerably oriented to their daily problematics. So with this demo, we was also hoping to demonstrate that using the ROS framework, we've been able to set up complex robotic application, modifying significantly the original one. The original ScanNPlan application was performed with an ABB manipulator. Here we switched to a FANUC one, using others camera and others laser scanner. And we use this application to gather various ROS-Industrial FATP to try to give some visibility to those amazing products. Also, we was using different other tools from ROS as a FlexB application that allow us to give some flexibility. So here you can see the actual setup of the demo. We are using the FANUC CL7 collaborative robot, which is able to reach 7 kilo payload and almost 1 meter of reach. The ROS-I driver is using to control the robot and to make the interface between the robot and the ROS framework. We're also using the ZVID 3D camera, which is a high precision camera with working with structural light. Actually, the driver is also a result of a ROS-I FATP. And using a custom driver for a Qualtech laser to perform quality measurement. Also using the FlexB framework that allows us to make some control of error and automatization of the entire app. And we also made some slightly change on the basic application, correcting some bugs and adding some minor extension to it. So let's switch for the live demo. hope it will doing well. I'll be changing my setup, so here you should be able to see the robot actually in the lab. And I will be showing the Ubuntu desktop, so you can see what we are doing also in the Ubuntu part. So here we have the ScanNPlan app with a different values panel, allowing us to control the app from different from a view, and we are here able to start a process and starting to actually use this ScanNPlan application. So here we can see the result of the scanning process. The photo in 3D has been taken thanks to the vivid camera you can see here in the manipulator. And we are looking from each plane surface on this photo. So here we detected 2 objects on the scene. You can choose to work with one or another. And the application now allows us to automatically generate 3 different trajectories. The first one will be the whole blending of the surface. Secondly, will be doing the whole contour of the parts. And we have a last pass of scanning part to show how good has been the process. So here we are able to simulate the process in case you want to assure you that the demo, the application is doing correctly. And you can execute each pass of it with the actual robot. So here the robot is blending the whole surface of the part. In second time, we detected 2 different edges on the part, so we can also use those paths and execute it. So I hope that you can see properly the robot moving on my webcam.
Yes, we can see.
Yes, good. And as a final process, we're also using the QualTape laser to do some quality measurement on the part, being able to actually verify if the process has been done properly. So here, I didn't specify it, but the end effector of the robot is coming with 3 different TCP. Here we are using the laser TCP. We have also one dedicated to the camera, the vivid camera, and the third one for the tool. So depending on what application, what movement you are executing, we are using a different one. So you can see that the laser is actually filling a new point cloud, which is actually another detection of the part that can be used to ensure that the process has been done correctly. In addition to this application, we were also using the FlexB environment that provide us some tool to automatize the entire application, do some control error, be able to log different problematic and we can occur during the application. So it gives us the opportunity to make a whole automatized process. So to show you a little more the versatility of the application, I will change the parts of places. So with the new setup, the application will start, I hope. Maybe experiencing some trouble with the FlexV app. Okay, so I won't be able to start it. Sorry for that. So let's do it the old manner. So here we are grabbing a new photo of the scene. You can see we are now just one part on the scene. We're actually generating another time trajectories for this new part. So we generated 3 trajectories, one for blending the whole surface, one for edge, and one for scanning. We are now able to simulate all 3 trajectories. And now able to execute the whole process with the real robot. So this kind of application really comes with a high versatility. We are able to work with different kind of parts that can be placed whatever you want in the scene. We are able to gathering different point of cloud if you are working with parts which are bigger, so that you can't have a correct view of it with a single photo. We are able to manage several parts at the same time, also adding some functionality to, maybe I will share the little video I have for backup here. So here's exactly the same video, the same process as you just saw. Actually changing parts. And you're also able to define different kind of trajectory as the application requires. As example, here for the same part, we are generating different trajectory. One will be using the biggest concave polygon to do the scanning, the blending part, and one which will be running the whole part and the whole field of the part. So that's it for this presentation. I hope you find it interesting and relevant. Thanks for your attention, and I will be pleased to answer to your question at the end of the session.
Thanks a lot, Paul, for a very interesting presentation. We have quite a few questions in the chat, but as you said, we'll take it at the end of the session.
As you want.
But yeah, definitely the audience is very much impressed with you showing the demo live and not a recorded video.
Good.
So kudos to that.
Thanks for the appreciation.
Yeah. So next up is Jon Scherchen from ABB Corporate Research, and he'll be presenting about ROS driver for ABB robots, and he'll be also showing a mobile manipulation demo. So over to you, Jon.
Yes.
Good. Okay. So my name is Jon Tjerngren, and I'm from working at ABB Corporate Research in Västerås, Sweden, and in the mechatronics and robot automation team. And I have a twofold agenda today, and I will be presenting this ROS driver for ABB robots. And then I will show a mobile manipulation demo, which is using the driver. Okay, and I have 5 to 6 years experience with ROS systems, and I've been working in several European projects, where especially ROS-I is one of the latest ones. So I will start with the driver and begin with some acknowledgements. And I said this ROS-I project I have been working in for the last 4 years, and also the ROS-Industrial open source community. They have both been very essential for this driver, and without these initiatives, it would be unlikely that this driver I will present here would exist. Okay, so the main objective of this driver is to, on the one side you have ABB robots, and on the other side you have the ROS framework and all the useful tools therein. And in the middle you have people and engineers and programmers and researchers and students and the whole academic world. So the main objective is to connect them in a nice way. And I think that providing high quality and robust ROS packages is a great way of doing that. Okay, so as a small recap, I had a presentation at ROS-Industrial Conference 2018, which also was due to the ROS-I project, where I presented some communication packages I had developed for interacting with the ABB robots. So I have naturally built upon those packages to create a ROS driver for ABB robots. And the driver basically consists of 3 main nodes, and this is to separate the concerns, to have it easier to maintain and also increase the flexibility. So you can use the parts that are useful or needed for the application in mind. So 2 of the nodes are using something called Robot Web Services interaction, which is for general purpose interaction. So you can use it to collect robot state and also trigger IO signals and starting the program running on the robot controller. And then there's another node for using something called external guided motion, which is more for direct motion control. And it's based on using ROS control based node. And so these nodes are basically ready to run after a short configuration. And now I'll show some videos. And I will begin with showing ROS on Windows, simulating in combination with ABB Robot Studio. And it's ROS on Windows is actually quite nice, so you can avoid proxy and firewall settings, so it will streamline the setup of simulations very nicely. Okay, so to the left we have RViz in Windows and a slider that I'm moving, and this basically moves the robot in Robot Studio to the right. So this was a very short video, but you can also have a more complex setup. So with 2 robots and a linear track and a positioner, and you can basically do the same after a few minimal configuration changes to the ROS side. And then a third video is for using ROS on Ubuntu in combination with Move It. So to the right you have Move It, and you can select a goal pose, and then send a plan and request, execute request, and then the robot moves in Robot Studio, and it is reflected in the RVIS application. And it finally went to the goal position. So this was very briefly about the ROS driver I had developed, and here are some key points. And the ABB robot driver packages will be released as is on GitHub, which means that this is not a product from ABB. So it will only be limited support that users can expect. And the open source release on GitHub is planned by end of this week. So the link in the bottom is currently leading to a private repository, but it will soon be public. And the intended audience for the driver is the academia. And the driver works well with both ROS on Ubuntu and Windows, so it's flexible. And the driver makes it quite easy to set up simulations between ROS and the ABB Robot Studio environment. And this can, for example, be used for automatic testing and simulations, and also to faster develop applications. And it makes it seamless to switch from simulation to a real robot. It basically just a change of IP address and maybe a port number. Okay, and there are some limitations for ABB robot controller types. So right now it's only IRC5 and RobotWare 6 systems that are supported. Omnicore and RobotWare 7 systems are currently not supported, but no decision has been taken for this yet, but it might happen. And for more details, you can see the ABB lib RWS and ABB lib EGM packages, which are the underlying communication libraries. And also right now there's only ROS1 packages implemented, but the driver has been designed so there's potential for a ROS2 port in the future. So hopefully you can enjoy it very soon. Okay, now over to the second part of my presentation about the mobile manipulation demo. And first off, a short overview. So last year, ABB showcased a mobile YuMi concept in Texas, or at Texas Medical Center in Houston, Texas. And here in the demo I will show here, it will be used for a logistics demo, which has been developed during this ROS-I European project. And yeah, unfortunately, due to the COVID-19 situation, it will not be on site in Stuttgart, as was the original intention, but we will be live streaming it later during the exhibitor time slots, both today and tomorrow at these times. Okay, so now I'll show a brief system sketch of the ROS system. So the mobile platform has a onboard computer running ROS, and we have a couple of sensors and cameras and a joystick connected to the computer, and there are some ROS nodes that collect that information and make it available to the ROS system. And we are also using April tag ROS for detecting these types of tags shown in the bottom. And then we have one section for the mobile platform, and these red boxes with white text have been developed by in-house. And we have one ROS node for a driver talking with the drive system of the platform. And then we have the section for the YuMi robot, which is using these ROS nodes that I previously presented for the ROS driver for ABB robots. And then we have a FlexB node as well, which is a behavior engine. And in there we have developed some manipulation, docking, and navigation behaviors, which we can trigger remotely. And then we also have an external computing also running ROS with a website for a simple store and a database and some backend for a web store, which is a ROS node. And we also have a customer and a worker in the lab. Let's say, so the customer can send a request, place an order for a certain objects to, let's say, buy, which triggers the back end of the web store to gather information from the database, notifies the worker that the order has arrived, and then it starts to request the FlexB behavior engine to, for example, start navigation, which triggers move base. And here we're using TEB local planner to create the motions of the platform, which then talks to the driver and moves it around in the lab. And then the backend can, for example, trigger a docking behavior, which triggers or sends a request to our own docking node, which is listening for these April tags, and then sends motions request to the driver and moves it around to, for example, to dock towards a table. And then the backend can start manipulation, which then sends a request to UMI sequencer here, which gathers a lot of information via the ROS state publisher about the current state of the robot, and then sends request to move it, and using PIL's trajectory generation, which is partly developed in the ROS-I focused technical project. And then those move it requests are executed through the EGM hardware interface and moves the arms. And then the UMI sequencer can use the RWS service provider to trigger IO signals to interact with the UMI tools. So that was a brief overview of the system. And now I will show a teaser for the live streaming we will have later on. So here I'm placing a request for some mystery boxes. And then I will send a buy request, and it will be sent over to the mobile UMI, which starts to navigate in the lab and goes to a shelf with the boxes. And here my colleague shows a list he's gotten on his smartphone to pick and scan and place them on board the UMI or mobile UMI. And then for another shelf and more boxes. And then the platform moves over to a delivery table and docks towards a table using this April tag and the camera images. And then UMI starts to manipulate and pick up the boxes from itself and place them on the table. And it will continue to do this until the boxes are unloaded. And then it will move over to a waiting location to wait for a new request. And here I will not show the content of the boxes. I leave that as a cliffhanger for a live streaming event. And that was it from me. Thank you for listening.
Thank you, John, again, for the very insightful presentation. Quite an impressive demo, I should say. Again, both of the demos you can see live during the exhibition time. I think that is from 1:30 to 2:30 p.m., if I'm not wrong. So you should be able to see that in the exhibition area. So I'm sure both the presentations were very impressive because we have a huge list of questions here. So we have enough time, I think, to cover most of them. First one for you, John. So again, is there any plan to productize the ABB robot driver, including support?
For the robot driver, there are currently no such plans that I am aware of.
All right. Yeah, Paul, one for you. So there is one question which asks that, is there still a manual visual inspection necessary after the process?
No, in fact, it depends on how you set the flex behavior. You can make it that required or optional, as you want.
Again to you, Paul, I think there is a couple of questions regarding the hardware you have chosen. One is basically, why did you choose the Fanuc robot? And also there is another question in the same lines, that why did you choose the Zivid 3D camera? And what is your experience with the ROS driver?
So the Fanuc times is about that we have the robot available here in the laboratory, and pending with the other projects that we had here in the lab. So we just take the opportunity to start working with it and approaching time for the two projects at the same time. So we have been able to start experimentation with this robot, and so now we are facing the same problematic of the driver with other Fanuc robots, and all the work we've done with the ScanNPlan application helped us a lot in this area. For the Zivid camera, in fact, we have here one of our colleagues who was quite involved in the development and in the creation of this camera. So we had the opportunity very soon to start to work with this huge camera, which is very fast, very precise. Actually, we get some point clouds that are quite precise, and use it in whole robotic lab was an objective that we had from a lot of time. And also I saw that there was a question about the driver of the Zivid.
Yeah.
So when we started to work with this camera, the first version of the driver give us some problematic, but the last one we experienced and the one we experienced with this demo is quite good. We had some problematic about the calibration of the camera in the robot, but instead of that, everything works pretty well, and it's huge to use in the ROS framework. I hope that I have answered the question and not doing
Yeah, thank you.
Out of subject.
John, next one is for you. How is the safety management done for YuMi? Is there a consideration in the process flow?
So for the YuMi robot or the mobile platform in whole, so for the YuMi robot, it's integrated in the robot controller system from ABB, that if it detects a collision, it will stop. For the mobile platform base, it's using move base and the laser scanner information to detect objects in a 2D plane. And we are also looking into using the camera on the back of the YuMi to detect 3D objects, like tables, for example, which are not seen by, at least the tabletops are not seen by the scanners, 2D scanners. I hope that answers the question.
Yeah. Paul, probably you can take another one question. We have some time, but let's see if we get more questions. So about the ScanNPlan application, could this application or a modified version of it be used on round objects like bottles?
So the actual demo we are running is just working with the planes. So this camera, in fact, can't. But there is an integration of the innovator planner that do include the curved surfaces. We made some experiment about this, but it do not working as we want. But it should not require a lot of work to make it run. I guess that's people from Fraunhofer success to use this innovator planner. So this is possible for sure.
So we had also a couple of polls. Of course, I think, Paul, you can already answer. It was just one quick quiz question. Can you name the GitHub repository name for the ScanNPlan application?
As we still have some bugs. We have not. We have a fork on the ScanNPlan application, but we did not publish yet all the modification we made. I think that we have to do this soon.
Okay. And I think the last question probably for this session I could ask both of you. That is also from the poll. So basically, as an end user, how confident would you be in using an existing ROS-based application stack on your factory floor? So, or at least what would you like to see that will make you confident to use those repositories on your factory floor?
For my part, we are using ROS every day, and we are quite confident that maybe I did not understand the question good, but we are using new tools of ROS every day, and it helps us a lot with very different field of application. So quite confident for my part.
And from my side, I've been using ROS quite a lot as well, and it depends a bit on which packages are used, but as long as you're a bit careful of what you're using and testing them out extensively, then I'm also quite confident. And I'm seeing that ROS2 will make it even better. I have mainly been using ROS1 for now.
All right.
Yeah.
So I don't think we have any more questions here. Okay, Jon, I think we can take one last question and then we can end the session. So this is one for you, John. Which standards did you use for your risk assessment for your mobile robot?
I need to ask my colleague one second. Well, this is just a prototype, and we have not really evaluated that at this time.
So thank you again, both of you, Paul and John, for the presentations. So for the audience, we are a bit early in ending the session, so probably you could have a short coffee break before we start with the next session. So I thank you again, both Paul and Jon, for the presentations.